Thank you very much. So around 2019 or so, my friend Yan Zhu, who heads optimization research at SAS, and I proposed and created a team called the Speed Doctors. And we began to systematically transform the performance of the Top-K technology at SAS. On Jared Peterson's suggestion, he recently asked us to try to do this with agents, so essentially replace our jobs. And we're nerdy enough to try our best to do so, and this talk is about doing just that. So I'm going to try to convince you why performance on the cloud is even more important off of the cloud, just because of the scaling. And if any of you have used Model Studio, you know with just dropping your data into Model Studio, pressing a few buttons, you can create schematics like this. Why do we create schematics like this? Well, given your data, it's impossible beforehand, nearly, to know which of these models would do best on your data. In the cloud, we don't have to pick one. We can run them all at the same time in parallel. Further, it might just be that neural nets is better than gradient boosting because the defaults just happen to be better for your data set. And with tuning, they can flip-flop. So we'll also auto-tune under hood each of these for you. Sorry, I went back. And what that means is with very little effort on your part in the cloud, you can create hundreds to thousands of really important jobs that give you a lot of great information about your problem. And they can all run in parallel, but you're still restricted to the time of each block to complete. Furthermore, as agents start to move within all the important points of intersection and decision-making in our software, we expect this to get smarter, but also to come up with many more ideas than a human would think of. So this queue of potential really important experiments to run is just going to grow. Now, you might think that we're just shotgunning out randomly a bunch of things and seeing what sticks, but really I would argue that what we're doing is putting science on speed rails. What is science? You come up with a hypothesis, an idea. That could be a pipeline, that could be a set of hyperparameters, and rather than arguing with your office mate about which is better and why the theory of one is better than the other one, you simply just run and see what the results, and let the results guide you and evolve as you go. So in the past, science had two major bottlenecks, and I'd argue that that first one was probably the greatest one before Gen AI, where probably a lot of the time you had compute that was running idle while you slept, while you thought of what to try next, while you tried to make sure you weren't running in circles, repeating things that you had tried months ago and forgot that you had. But with AutoML and caching and agents, this is pretty much gone. You can continue to do that process, but these agents are going to think of lots of great ideas to do. So you're going to have a very almost endless queue of things to try. So truly the bottleneck that's going to slow down science and how fast you can move is going to be how quickly you can process those jobs on your corresponding hardware. So this is a slide just to argue that the heart of everything, how fast science moves, is going to be stability and speed, making sure you're getting the correct answers as fast as possible. The faster you iterate, the faster you learn, the faster your agents are learning, the faster you're able to progress. So this is where our team came into play. This is kind of like our icon, our symbol. And we noted that if you get experts in hardware, software, and mathematics speaking the same language, you can, without upgrading your hardware, without buying a GPU, without adding more cores, get astounding performance improvements if you have a system to do so. And I'm going to give you kind of an example of how it works, what we do on a day-to-day basis when given a target to do so. So I'm going to break into a quick demo just to show you. You could do this yourself, and I could give you this file if you wanted. Okay, cool, happy to share. So here what I'm going to do is just, without loss of generality, this is just going to be two randomly generated data sets of, it's not showing my desktop. Do you know how to switch it? Okay, sorry, this worked earlier.
Right now it's mirroring, so you can go to whatever program you need.
Oh, thank you so much. Yes, big hand. You saved me. Huh. Okay, so it's showing. Okay, so I've generated here 2 random data sets. And it might not be obvious to you, but underneath your analytics, the distance matrix calculation is kind of ubiquitous. It's in SVM for radial basis functions. It's in k-nearest neighbors. It's in nonlinear PCA. It's in Bayesian modeling, and on and on. So it's a really key, important thing to be able to do rapidly. Essentially, it's not too interesting. You're just looping over the rows in A, looping over the rows of B, and calculating the distance norm. So if you were to just look at the mathematics and minimize flops, you would simply do something like this, where you're looping over the rows of A, looping over the rows of B, and calculating the distance, and this taking about 3 seconds on my laptop, which I think it's clear that if we try to scale up, this would become prohibitive for you. So how can we make this faster? Well, if we look at the hardware and what's happening, we're getting a lot of cache misses when we do this. The hardware wasn't designed to do loops this way. But if we look at the mathematics of what we're actually calculating, this A minus B norm, and we expanded it, you see you have this inner product that is suggestive that we could do this with a matrix multiply and some corrections. So this code is much uglier, but it's just reposing it so that I can use a matrix multiply to get this job done. And now for this run, you're getting the same results to machine precision, but you're 170x faster. I didn't ask you to buy a GPU. I didn't try to thread this. I didn't do anything complicated. I just made the algorithm fit better for the way the hardware was designed by knowing more about the underlying hardware. So oftentimes developers will like to mod out and pretend like the hardware is all the same. But it's really critical, if you want top performance, to meet with hardware folks and know how these machines were designed to run. So hopefully now I can flip back to this one. Great, okay. And so doing just that iteratively, going from top K technologies, the ones they pointed out that they wanted us to improve, running experiments, looking at the bottlenecks with laser focus, we were able to get this 30x performance. This is a Futurum report, so externally vetted. We weren't allowed to put our thumbs on the scale on this. And if you remember the opening session, little self-promotion, Brian Harris mentioned these results while talking to Dr. Goodnight, and this came from our team in that hard work. So now our goal is to rapidly expand the ability of what our small team can do for all of you by creating, in a sense, digital twins of that. So now I introduce these performance agents. Now, essentially what we do, and what can't be automated, what can, is when we have a problem, is we'll create a bunch of tests. We'll add instrumentation to those tests. We'll run them in parallel, and we'll get results, so we'll know exactly where all the bottlenecks are occurring. They'll follow a Pareto distribution, so a small fraction of your code is going to cause most of the sickness. So we don't have to boil the ocean in order to be able to fix the code. And then we'll look at those small bottlenecks, and we'll go offline. We'll look at to see what others do in those circumstances, and then also what we might think of on the cuff. And so really the only bottleneck, the only thing that we couldn't automate in the past, where we had to be present, was for that stage where we were thinking, what is this code actually doing, and how can we reformulate it to exactly the same thing, only 10x faster. And so this is the vision where we're going to replace ourselves with an agent. And so instead of it having to wait for we have time to reformulate it and do the research, this agent will do this continuously offline for you when prompted. And the idea is that when you're in SAS Studio and you're running and it detects that you are running a long time, it would ping you and say, hey, would you like us to go offline and try to make this faster for you while you do other things? And so the name right now, usually we're not allowed to pick the name, so it'll probably change. We're calling it SAS Perf, and this is the group of agents that are doing that. And they're going to set up the instrumentation for you. Since we usually work in C, but now we're lifting into the SAS dimension, we're using things like full S-timer and SCA proc, and we'll put them strategically around all the choke points so we can know exactly where the bottlenecks in your code live. And then we'll tie those results to LLMs and MCP tools so that they can begin to reformulate just those spots to improve it. And so essentially, when you're creating an agent, it's a mind-body game. The agent has the brain, but you need to give it hands and feet. So the hands and feet are the ability to act on your environment, to replace segments of your code with candidates. They would save all the variations that they do, so you'll be able to look at everything that was done, of course. and then to be able to execute, but then also have the brains to look at those results and, like a human, think of what they would do next. And they're getting scarily good at this, to be honest. And again, this is just the scientific method in disguise on steroids in parallel, where they're going to try and experiment, analyze it, think of a hypothesis of how to redo it, run it, make sure everything matches. If it's faster, keep it. If it's not, continue. So, of course, from your perspective, we don't want you to have to know about all of this pieces that are going on, all the puzzle pieces, the kind of symphony of agents working together. You would just input your code, and you would get outputted, hopefully, faster code that's been optimized, that's been verified to do the same thing that you did before. Inside, there's going to be a lot going on with RAG servers, knowledge bases, hotspot analyzers, validation, instrumentation, the SAS code running in parallel. You're in the cloud, so if you wanted to, you don't have to try one hypothesis. You can try 10, 20, as many as you're willing to spin for nodes to do that. And again, this is the ultimate North Star of what we would want to have under the hood for you, where the SAS perf agent is going to be orchestrating all this. There'll be sub-agents, sub-skills, working to look at different hotspots in parallel to try to eliminate them as best as possible. And in particular, if you're coming from SAS9, modernize your code strategically, not change everything, but change the things that with a small swap out of a new VIA proc would allow you to run much faster. And this is just some of the things that are going on under the hood for you with RAG servers that will evolve over time, skill sets that will evolve over time. So we're hoping the agents are going to get more and more tools to set them up for success, while the agents themselves, we know, grow on a daily basis with smarts as these LLMs grow. And of course, again, just to emphasize, it's not just going to be one of these loops running sequentially at a time, but we're going to be running a bunch of them, have multiple agents working on different agendas, making sure they're talking so that they're not doing the same thing, but a diverse set of ideas being tried in parallel. And this is hopefully going to allow you to go offline, do your hobby, do your errands, meet with friends, and hopefully it will ping you when it has something interesting that's worth looking into, and then you can drill down or look at it later, but you'll know when you've caught a fish, in a sense. Now, I'm going to be doing some live demos. I've just learned to drive them myself on Friday, and it might crash. I wanted to show you what it should look like if I have any issues. So we're going to give you plots like this, where you'll see a graph of how, like, if you have really expansive code, there's going to be a long graph of the data flowing through different disjoint islands, possibly. And these red arrows are going to tell you where your bottlenecks are, and then you also have, other views of those same bottlenecks. Why that's so critical is what we found oftentimes is that the bottleneck that exists in your code is not the bottleneck that you think it is, and that's opportunity in disguise. Because if the bottleneck is what you thought it is, it's probably why you're not picking up the phone and calling tech support. But if you knew what the bottleneck was and it shouldn't be a bottleneck, then it means you can fix it. And so oftentimes, just knowing where your bottlenecks are, that's all you need to actually solve the problem, even without agents. So now I'll show some of the low-hanging fruit, why we know that there's a lot we can do here, but there's a lot of low-hanging fruit that we already know agents are going to be able to easily do for you. So how many here know what is the replacement for proc logistic? One? Yeah. Right? It's proc log select, and it's a lot faster. It runs on CAS. It's distributed. It's multi-threaded. It's where we put all our effort for the last 5 years, whereas logistic has kind of stopped in place. So if you've come in, you could be leaving that on the table. And if that's bottlenecking you, an agent could simply replace it. And the developer who created the log select would know how to create the skill to make sure it's one-to-one. How many know that we released a new nonlinear SVM solver that's 100 times faster, for the first time fully distributed, embarrassingly parallelizable in a sense, on March? So you might not know that you could make a small change to your existing code and be 100 times faster for something that might be running prohibitively long and actually do much larger data sets. And these are results where we're taking things that are hours on external open source, best of state of the art, and bringing it down to seconds. All right, so now I'm going to try the SAS perf demo. Wish me luck, because periodically I run into issues. But I do have the reports up just in case. And again, this was developed by developers. We haven't yet put the pretty UI, UX skin on, so please bear with me. It's just done in the command line. So I'm going to start. Some of the ones are longer, and I think we don't have time to go through it, but these are examples of code that we've analyzed to improve. But I'm going to start with just those two examples I mentioned, logistic. And all I'm going to do is, again, what I'm doing right here would be done when you said to the agent, yes, help me make this chunk of code faster. Under the hood, it's going to do something like this with an MCP server. And you'll see it's going through those same steps that we mentioned in the charts. It's validating the source. It's adding instrumentation to your code. It's executing a baseline. Sometimes this is fast. Now, sometimes it's slow. So I'm going to go ahead and jump to what you would ultimately see. Again, this hasn't been through a professional UI, UX team, so bear with us on what it looks like. But this is the kind of report that you would get, module. Hopefully it'll be pretty and more readable. It would come with its own agent here that would be able to answer your questions about the report. So it might be too verbose, too much information, so you could shrink it down. You could ask it any questions about why it chose to do what it did. You'd also have all the different variations. Right now, that just did 3, but you might have hundreds of variations. It might have done something that isn't faster, but is very interesting to you because you didn't know that it could do that. You could ask the agent why it did that. And then it'll come down, and you can do a split view to see the two. Let me see make sure that works. But on a monitor, it's kind of hard. So I'm going to show you the baseline kind of information. So you have a plot of where your time was spent. You have these charts that aren't that interesting for these toy problems, but would be. And then we're also showing you top down what was taking the most time for your given problem. And you always want to spend, where you're going to get the most bang for your buck. In this case, the logistic is doing them most of the time. So now we're going to look at the optimized version. Again, you're going to still see where the hotspots are there. You'll get a chart. Sometimes this moves when I scroll wrong, but then you'll also get the list of what was causing the most time, and you can look down and see the code that's corresponding to those snippets. But here, if you remember, it was I think 2 seconds, and now it's 0.8 seconds. And for a much larger problem, in general, I think we've gone around 5x to 10x faster speed across the board, switching there. And of course, we would do the same thing for SVM. Let's see if this one finished. I'm always picking the wrong one. There it is. What? Oh, here it is. I have to open this first. So this is a report that was generated. It hasn't finished doing the optimization side, so I'm going to go ahead and skip that. But at some point, that would be populated with the best that you saw for that time. And then I'm going to cheat a little bit. So for like adult SVM, this might be your pipeline of code that you're running. And I think we could all argue it would be trivial for an agent to know that whenever it saw active set. So first, let me try active set here, show you. Let me run it. This runs about 20 seconds, unless something goes wrong. And when we switch it to the RSVM, you're going to get the same accuracy, but like in a second. So let's see. Still running. So I'm on a shared server. So, okay, yeah, 20 seconds here, if you can see. And now I'm going to do RSVM. Right, so surely agents can make that change. And now it's done right away. And the time was 6 seconds. And for some reason, there were other results, but both of them were getting around 78 accuracy. So same accuracy, but 20 to 1 second. So This would be a way for you to modernize your codes, but also to come up with using a lot of the tricks of the trade that our experts know that we would bake into the agent for you to be able to use. So in closing, and I apologize for the roughness of that we put probably too many things together at the same time. But we're really just getting started, but I think if anyone's played with agents, you know that we're trying to do obviously should work as long as we have access to the experts, which we do for these procs, to create the skills that would make sure when these procs were the bottleneck, it would know how to transform them and optimize them. And then, of course, validate, make sure you're getting the right results. Our first generation that we actually created was for us, and we did it with C, and we were kind of blown away. And then Jared said, let's do this for SAS as well, for you all. And so we kind of paused that one and have been working on this one. And so if you like what you see here, you have to beat the drum because there's tons of agent work going on, and we're constantly triaging. This was partially triaged for other things. But it's really exciting, and I think almost mathematically provable to be doable just because of how we know agents work. So with that, I'll close, and I'm happy to take any questions, thoughts, comments, feedback.
Any questions? All right, let me get on to somebody else then. I'll
Anytime.
get back to you, all right?
So in one of the earlier diagrams in your presentation, there was a little section referred to as knowledge base. And I think verbally, one of the things that you also said is that when a user is applying one of these agents to their code to look for optimization, it will also be compared to code of other users. Is that right?
It would be compared to itself to make sure that there's not, like, if you replace logistic, nonlinear regression with linear regression, it could get faster, but your accuracy might drop. So it's mainly making sure there's no churn. Well, in the knowledge base, yes, we would be going to like the cookbooks and try, there it would be looking for any lesson learned we would save and make sure that we could apply it to you in the future rather than, waiting for someone from tech support to call one of us and then we do it manually. It would, yes.
In the knowledge base, which is comparing the code being submitted in one instance to past existing code, is any metadata being retained about the source of that earlier code, or is it being anonymized? So this is a security question, really.
Yeah, well, for sure, this is, anything that's customer related, we're not going to be able to keep, right? But anything that we've done, like our own experiments, our own hackathons, those things would be kept. But yeah, you would, it'd be really hard for us to get permission to keep anything that we did for you, for sure.
Okay,
So, someone might create a question that says, can we share it? And we'd love for you to do so, of course. But yeah, security first.
So even though it's faster, does it compare the results?
Yeah, that's something that we're baking into it. We're going to bake some default comparisons using proc compare, but we're also going to put in a little caveat that it's up to you to also check, because what we would check for might not be what is most important to you, and so we might ask you to, and the agent probably could help you write, you say I would like to make sure these things don't move, and then it would write code in SAS to make sure that those are within specs. There's always going to be some round off no matter what you do. You move to a different machine, the orders of things changes with the mantisas.
Could be more correct.
Yes, you could always go in the right direction. Usually, if it's, oftentimes that's the direction it'll go, but not always. Yes. Good question.
Just a quick question. Are those agents like a inbuilt to the tools, or they are like a separately licensed or anything like that?
These agents would be part of SAS, and they might sit on larger LLMs that work well that, we'd have to negotiate that. We're not, at this point, hopefully we're not trying to build our own LLMs as a base, but the agents on top of it would be stuff that we would write and would be part of SAS. I don't think it's that hard now. It's getting easier and easier to create agents. So we would, create our own.
Thank you.
So hopefully no cost to you would be my preference.
All right, I got time for one more question. He's got one. Who else has a question? It's kind of now or never.
Now or never. Okay. So I've been doing a lot of research into the architecture behind the data and making sure that you get the right deployment put together. And I see companies everywhere just going the wrong, zigging when they should zag. What do you see as the big impact on system architecture itself based on this? In other words, a lot of companies are wanting to go to, I can't believe I'm saying this out loud, they want to go to public cloud and buy a timeshare for their data.
Yes.
Yeah. Can we stop them from doing that with this for the most part and keep the real important stuff either on-prem or local or something like that, rather than giving it to Google and hoping that they don't lose it?
I would hope so. I mean, that's probably outside my pay bracket to answer, but as far as it being doable, I don't see why not.
But would there be leverage to do that?
That would, customers are the boss, so like you would create the leverage, and then we would be charged with creating the reality. So if there's enough pressure on that, I think that would, I've seen that multiple times where customers push really hard and we'll take right turns, for better or worse.
All right. Thank you, Joshua.
Thank you.